Hello, everyone. Welcome to episode 51 of the Day Zero podcast. I'm Spectre. With me is Z. Good day to be inside doing the podcast because it turns out today was also the first day of snow for me. It's a winter wonderland outside, and the ground is basically a hockey rink. So, yeah, good to be inside doing a podcast. Um, so, today we'll be getting into some Windows bugs, a Wormable game RCE in Alien Swarm, and the newly announced Cert 300 course by Offensive Security. So we will also probably be getting a guest on for a fuzzing research topic as well. And as such, where we usually do the research towards the end of the episode, we're going to be moving that up to right after we cover the news. So, with that being said, let's jump into some news. So, cybersecurity, as we know it, will be a thing of the past in the next decade, according to the Cloudflare chief operating officer. So, yeah, she was quoted as saying, I have a point of view that cybersecurity is going to be a thing of the past next decade because I think technology is going to solve these problems. Saying it would basically transform into a water treatment plant like system where untrusted data goes in and filters like Cloudflare will cleanse it and only allow clean data through. Now, there is a bit of a disparity between what the article says she says and what they actually quote. The quotes make it sound like she legitimately thinks security threats will just, disappear. But there's other paragraphs in the article that state it's not that technology in the future will be threat proof. Instead, cybersecurity systems will weed out bad actors earlier in the attacks, which isn't quoted. I have a bit of a problem with this disparity because that paragraph regarding bad actors being weeded out earlier, I can agree with. I think automated filters and stuff will improve over time, but they don't quote that, which is weird because they seem to quote everything else. I know it sounds like I'm being a bit pedantic here, but these quotes really do seem to conflict to me. The quotes make it sound like we've solved cybersecurity, while the statements in the article seem to be a lot more reasonable. So that being said, taking the quotes directly, I think this is either drinking the Kool-Aid or a marketing push. Probably a bit of both. There's an obvious marketing angle to this. Cloudflare provides services like what they're trying to bolster up here. The Cloudflare web application firewall. Um,
I mean, I
Overall, though,
I think kind of being fair here though, it does say cybersecurity as we know it will no longer exist. Not cybersecurity is not going to exist, just as we know it, there's going to be a fundamental change. And I think her quotes are consistent with that, being that the fundamental change being as they describe this water filter paradigm, having just kind of a filter in front of everything that takes care of security.
so here's the weird thing. You're right. The title does say cybersecurity as we know it, but the quote directly, she says, I have a point of view that cybersecurity is going to be a thing of the past, not
Fair.
cybersecurity
Yeah,
as
I
we know
was
it. So that's what I'm saying. Like, there's a lot of like disparities in this article that makes it hard to know what exactly her stance is. I don't know what the article author has put in there and what she's actually said. So it's a little bit weird there. Overall, though, I think it's fair to say that filters will improve, but you'll never be able to get everything. And that this also assumes that everything is going to be put behind such a filter, which is kind of a bold statement in and of itself.
It is,
Um,
but if you look at the past 10 years and just kind of try to extrapolate, you can kind of see that. I mean, I think the key thing is going to be we've already got the web app firewalls. Those are gaining in traction, but what about other applications? That's where right now we don't really have a lot of those systems, or at least that I'm aware of. You do have like the IDS, IPS stuff that's going to be running, but you don't have some that's really able to kind of filter and strip the traffic to the same degree as you've got with like a web app firewall. So I can see that as being an improvement in the future. That said, it does kind of ignore many vulnerabilities that just can't be caught that way.
mhm. Yeah, exactly.
I mean,
Which is
any
why,
sort of business logic issue, you're just not going to capture by just filtering it. You might be able to catch, the cross-site scripting, the SQL injection attempts, but I mean, ultimately, a lot of the filters tend to just be along the lines of a blacklist, which we generally see as not a great option.
yeah. So I think I'm going to be a bit charitable here and say that she did mean as it is today. I don't think she means that security is just going to not be a concern next decade, because I think that's just too absurd of a statement to make. But I think the article is kind of does have a bit of blame with those disparities that I talked about earlier. I think it should have been written a little bit better and made it more clear what the actual stance was.
Yeah, no, I agree. Like I initially pointed out there, exactly what you had to point that out to me after I made the exact same mistake by just looking at the title there and not
Yeah,
noticing the disparity.
yeah. That said, we can move on to a researcher's guide to some legal risks of security research. So, Suno Park and Kendra Albert from Harvard Law School, in collaboration with the EFF, put out a guide of legal risks to security research. And this is a very cool thing to bring up, because the question of legality when it comes to security is one that's existed for ages and has changed a lot over time. Though this is with a focus on US law, so it might not be as applicable to other countries like European countries. So the first few pages talk about legal risk and the types of legal liability, distinction between civil liability and criminal liability, as well as cease and desist and obligations that are involved there. Now, a really useful page for those who want a summary, I think, is page 7. They have a table of areas of law and where those could apply to which activities. So, for example, the most obvious one is the Computer Fraud and Abuse Act, which is when you access a device you don't own and don't have consent to access. But there's also some lesser known ones in there, like the Export Administration Regulations Act, when it comes to transferring code or equipment related to cryptography to foreign destinations. Um, so we're not going to go into all of them, because there is a lot of nuances there that are applicable to each of the type of laws they list in the table that they go into in the document.
Yeah, and I will just quickly mention there the Export Administration Regulation one. They do actually call out that the government has never invoked that against researchers. I do think that's kind of worth pointing out. Some of these are a lot more practical in nature, or things that you should be considering. DMCA being an obvious one that does get a lot of researchers dealing with the anti-circumvention stuff. But the export one, as they even state that it's fairly unlikely and would be a fairly unusual circumstance for it to be pushed against a researcher.
Yeah, it will be interesting to see if that changes. Because would that be the act that would be enacted if you, let's say, sold an exploit to an organization in like a foreign nation? Like, could that?
No. No,
No.
this
Okay.
is mostly around crypto. So this is the
So
crypto
only crypto.
wars.
Okay.
Yeah, this is like the 90s stuff.
Okay.
Back when it was like it's crypto arms, or defining it as an arms and all of that.
Okay. One other section I did want to shout out is the FAQ when it comes to attorneys. Some of the questions in there, like, does talking to a lawyer make me look guilty or increase risk? And where can I find a lawyer who knows about security research? And some of the other ones. These are, I think, are very valuable answers to have and are common questions. Um, I found this page most interesting because they're definitely questions I've had myself in the past, especially on the point of where can I find a lawyer who knows about security research? Because security research is one of those niche areas where it is hard to get in touch with someone who has both the legal ability on that angle, as well as the understanding of the nuances that are involved with cybersecurity. So their advice there is to reach out to the EFF or the Cyber Law Clinic, which the Cyber Law Clinic I've never actually heard of. I don't know if you have, Z, but yeah, just some really interesting answers there that I think might be valuable to people, especially if you're doing something that could have you're walking on like a legal gray area, right?
I
Like,
mean, I
let's say
would
you're reverse
say
engineering some big product or something.
I would say give this a read, even if you don't know whether or not you're going into a gray area. I mean, I think the key thing with this paper, yeah, the FAQs are, actual frequently asked questions that you might have, but just the entire paper when they talk about what legal risk even is, what type of risk you could be taking on, and then obviously the overviews we discussed earlier of the different sorts of issues you can run into. If you're not already aware of that, it's a good summary of what those issues are, what you can be dealing with. So I would kind of leave it as, I think you should read, even if you don't necessarily think you're in a gray area, because a lot of people make mistakes over what they can and can't do. I mean, we have covered some of those cases. I'd say it's better just to read it regardless to see where you're walking, rather than just if you think you're in a gray area.
Yeah, I think this is the first time I've actually seen these types of questions being tackled from people who actually have a legal background. I can't recall seeing like a paper or anything put out in the past on this subject. So I think it's pretty big, and I think this should be shared around more, because these are the types of questions, like I said earlier, that have just been asked for a while by so many people, and it's constantly like evolving, right? As security becomes more accepted, I guess, in the legal and ethical stance. So yeah, good to see some stuff about that. So we have a follow-up to the exploit fingerprinting research we talked about in episode 47 from Checkpoint. In that post, they tracked the Valadia exploit developer group who sold to malware devs and crimeware. In this one, they focus on PlayBit, which is another group that also does Windows kernel LPEs for crimeware groups. What's notably different about this group, though, is the fact that they don't develop zero-day exploits; they develop end-day exploits. So this research started off with an initial sample of Fruity Armor, which was discovered by Kaspersky and used CVE 2018-8453, which was a Win32 privileged escalation. And then after doing some initial analysis on that exploit with the fingerprinting techniques they found in the last article, which we covered, they managed to attribute 4 other CVEs to them and the malware that used those CVEs. So some of the malware that included those exploits was Dire, Ramit, Locky, Lockcrypt, and Fruity Armor, as we already mentioned. Um, all the exploits had exploitability checks that checked the patch date before attempting to run, which provided some useful information to Checkpoint, as they were able to use that to build a catalog of patch dates for the vulnerabilities that they used, tracing back to the patch Tuesdays that were involved. There were some common threads between all the bugs used that I found interesting, aside from the fact that they were just end days. All of them were in Win32K, which isn't surprising because that code is awful and old. But they also use a custom import technique they developed. They don't just import functions at the PE level or resolve them using get proc address. They import them via CRC hashes. And that was one of the fingerprints they used to tie back other exploits and tools that this group wrote. They also share an info leak primitive for leaking kernel addresses. They use the desktop heap stored in user mode through the Win32 client info field and the thread environment block, which is a design issue. It's not just a mistake like uninitialized memory or something. This is kind of a highlight of how Windows is really screwy when it comes to how easy, at least at the time, it was to defeat something like kernel ASLR. Windows often they're trying to fix it now, but for a while they place kernel pointers in user space by design, which is not a great idea. So they shared some information on the info leak side as well, which is something that you don't always get with some of the Windows exploits. Um, and then finally, they did an intel report on the group, which they didn't do that on Vladia, if I remember correctly. It's pretty funny. They ended up finding a YouTube account with videos of the exploits and POCs running, mostly as marketing material for selling the exploits on forums for malware developers and stuff like that. Which they also found. They found posts from a user named Luxor2008 selling these exploits on multiple forums. So they were able to tie those two names together. Um, their fingerprints also attributed 2 other tools to the same group as well, or at least tools that they helped on: the Avatar Rootkit and Eternal Black. So this was just a really I think this post offered some cool insights on the threat intelligence angle. And it's also a good demonstration of how 0 days aren't everything. End days can be very powerful too, as shown in this post, especially in Windows, where the update process sucks to the point where people just don't want to update. I mean, some people go as far as installing update blockers because the Windows update process is so annoying and can be so broken because of certain driver vendors. Um, End days also make a lot more sense from a malware dev point of view because they're far cheaper. 0 days are in the like 6-figure range typically for Windows, whereas end days are advertised at like 5 to 10K. Uh, they're far more accessible. So I wonder if we'll see more posts from Checkpoint on this line of articles, like an ongoing series. Because they do provide some cool insights that I haven't really seen in other places. They seem like a gold mine for threat intel people like Anti.
Yeah, I mean, I'm hoping we'll see more kind of like this. I kind of like the overlap with the exploit dev and the threat intel. It's not something that we end up getting a lot of. I have to feel like, maybe an anti's line, they're doing a lot of this already or already kind of familiar with the process, but I don't have a lot of exposure to it myself. So I
Yeah, I
like
mean,
seeing it.
I don't think this is super novel in the way that, like you said, this has already been done by, those threat intel companies, but they never make it to the public eye. So that's where I think this is really kind of breaking new ground on bringing that to the public front. At least I haven't seen it brought public anywhere else, really.
Yeah, no, I haven't seen it publicly done either.
But yeah, I think if there's one like big takeaway from this post is it's that just because a bug is patched doesn't mean you're safe. NDAs are still extremely valuable for crimeware and ransomware because they're so much more affordable and they'll still be able to hit a lot of people, especially on Windows, like I was saying earlier.
Well, as far as I'm aware, like most exploit kits, actually, I guess exploit kits are kind of dying in popularity these days, but a lot of that, like most people, like just your standard user not being targeted specifically, is going to be infected by these sorts of end day exploits, not somebody dropping an O day. So there's value in it in terms of like people are kind of buying them, but as you've already pointed out, like the value of the end days is significantly less than an O day. But that's also why just keeping yourself updated, going through the annoying update process on Windows, keeping your applications updated is just a key thing that you can be doing to keep yourself secure, because most of the attacks that are going to be launched blindly are not going to be dropping O days against you.
It's just not worth it in most cases.
Yeah, if you're going to pay that much, you want to get good use out of it, and when you just send it out in mass, it's very quickly also going to be found by the antivirus companies, and it's going to raise a lot of alerts.
Good way to get it killed quickly. Yeah.
Yeah.
So, in early September, Offensive Security announced OSCE and Cracking the Perimeter were being retired, and now they published one of the new courses that's replacing it. It's a pen testing course titled Pen 300. Z, I know you like talking about offensive security trainings, and you were actually the one who let me know about this, so I'll let you kick this one off.
Yeah, so we actually, with OSCE being retired, they're releasing 3 courses. We've briefly talked about this before, but the 3 courses, a web course, pen testing, and a user land exploit development course. 2 of those have been released now. I talked about AWA, which is their web one, back in would have been over a year ago already. I thought I had the episode noted, but it doesn't look like I do.
I think it was when our
Oh,
episode
episode
counts were still in
11.
a single digit. Oh, okay,
Oh,
just barely past single digits. So,
yeah.
yeah, it
So
was a long time ago.
episode 11, we talked about this Web 300 course, as it's now being called, or AWA. So this is Pen 300. OSC did have kind of those 3 sections, the web section, and this kind of antivirus evasion and some network layer stuff they're calling like the pen testing area. This looks like a very thorough course. So I have not taken this course yet. I'm really only going off the syllabus and what I'm seeing other people talk about. One of my biggest complaints with the web attack one was that the lab basically just contained a few vulnerable machines that you were directly walked through pretty much, and that was it. And whereas with something like OSCP, the value of that is the lab having over 50 boxes kind of blindly break into and work through. So it seems like with this course, they do have a lab of at least 20 boxes, some of which are blind. You kind of approach them in different ways. And the course itself is focusing on, they do include kind of the antivirus evasion. They do include, well, let me pull up the syllabus here actually. It's a 700 page course guide that you get with this. So it is quite long. And actually, as I was going through the table of contents last night, I just felt like, does this end? Because it just keeps going and going. It's covering a lot of things from OS and OS concepts about like Win32 API registry, goes into abusing Office in different ways, VBA to drop something, calling Win32 APIs from VBA, shellcode, PowerShell abuses, some C# stuff, JScript. As I already mentioned, the antivirus evasion, both Windows and Linux stuff on there, dealing with like UAC bypasses, dealing with Microsoft Defender, application whitelisting. Like there's just a ton of content in here that seems reasonably practical to what you're actually going to be doing these days in terms of post-exploitation. So you get your way into a box. Now what are you doing? How are you going to pivot from there? How are you going to move forward? It's got a lot of that. It does have a little bit of breaching the defenses, like I mentioned, like creating some droppers and such, getting that in with Office. So it does cover that also. But a lot of this seems to be kind of that initial post-exploitation, talks about building your own like process injection methods. It just covers a few of the basic things for that, but there's a lot of content in here. It looks like it's going to be a really solid course if you are trying to head into the pen testing area. So I just wanted to shout that out. It just launched recently. One thing I'm not a big fan of, I kind of get their reasoning, but it still feels a little bit like they're just pushing for more money, is you can't buy 30 days of lab time with this. You have to do a minimum of 60, which just pushes the course price up a little bit.
Yeah, I think the course price is $1,300 all in all for lab time, cert, and course.
Well, so you can get with different amount. You can still get with 90 days of lab time, so that would increase it by a bit.
Yeah, for 90 it's 1,500.
Yeah.
So
but
I
they
can't
did
remember if you
remove
mentioned
the 30.
Yeah, I can't remember if you mentioned, but it is worth noting this does bring in a new cert as well, the Offensive Security Experience Penetration Tester cert. It's intended to be taken after OSCP, though I don't think that's required. I think they just
No,
strongly
it's never
suggest that.
required. I mean, OSC was intended to be taken after OSCP also.
Yeah. So with the increased price point and how much you said it covers, it does sound like it might be worth that increased price with how much it covers. I don't know if you would agree with me on that, Z. Though I don't think we can really say for sure until we have more information and maybe some reviews around the course. I do
Well,
find.
it's the thing is, like 1300 is about where OSCE was, I believe. I don't actually recall what I paid for OSCE, but
I was trying to find the price and I couldn't find it anywhere where they've redirected the page to the fact that it's retiring. So
yeah,
I
so
really tried to get it, but unfortunately I couldn't.
I'm not sure what it was, but that does seem in the ballpark. Like it was more expensive than OSCP. That said, for the new OSCE, or they're calling it OSCE cubed because you need 3 certifications, that price goes up by quite a bit. Because obviously you're needing to pay for the advanced web attacks, this one, and the exploit development one that comes out.
Yeah.
So like that price becomes quite a bit higher. I don't know. I don't feel like Offensive Security is charging outrageous prices for their training, for their certifications.
I
Like
mean,
I do
consider the
feel like,
fact that there's places like Sands that charge like what is it, $7,000 for their
yeah,
courses.
7 to 8.
Yeah. Compared to that, this is pretty reasonable, I think.
Yeah, in-person training. So SANS kind of models itself on that in-person training. They do tend to be more expensive. Like if you take training at a conference or something, it does tend to be more expensive. And no, with OffSec here, like I don't feel like they're really scamming anybody. I would feel like generally, I think their courses are somewhat worthwhile. I've already shared my thoughts previously about how I did not like OSCE. Like, I do feel like that was just kind of a worthless certification to hold. I do feel like this, though, has a lot more of a chance at being something decent. Now, it is pen testing, which isn't really my wheelhouse. Like, I've done a handful of engagements involving it, but it's not my focus. I've always been more on the AppSec, more on the Vuln research side. But given the offensive security name, given what I see covered by the course, I do think it's a very promising certification. It's going to take some time for like hiring managers to see the value of this specific course. There's going to be the value just because it is attached to offensive security. There's going to be that name recognition, but it is going to take a bit of time before people kind of recognize this specific certification as its own thing rather than just as part of the offensive security general, like just part of their general offering.
So this is a really minor thing, but I found it interesting they're naming the course after a more academic type name scheme. With like Pen 300 instead of just like I don't know. It just seems weird having the numbers on there. I'm not sure exactly what they represent. Not that it's a big deal. It's just something I found interesting.
Yeah, no, it's clearly going for that university course style numbering.
Yeah.
OSCP might be your Pentesting 100. And then you get these courses, which are like your kind of reaching the end, your third year courses.
So kind of like what you were saying, pen testing isn't really my thing. It's not something I'm interested in. I think what I'm looking forward to more though is they shout out at the beginning of the article that there's going to be the Windows user mode exploit development course coming in early 2021, which is what you were kind of touching on earlier. EXP 301. That sounds like it's a lot more like up my alley and might be something that I would be willing to try. um, Potentially, because Windows has always been something I've kind of wanted to break into, but just never bothered to or never got to. So taking a course or something like that would be cool, and I would be able to do like a review, kind of like what you were doing with OS or sorry, AWAE was it last year? So yeah, I think I'm looking forward to that course a lot more. So we'll bring that one up as well when it ends up dropping in early 2021.
Yeah, that's probably the one I'm most looking forward to out of this split up of OSCE is the exploit development one. I'd still like it if they moved OSEE to be an online offering to make it accessible for people to take when they're not at Black Hat or Black Hat Europe.
Which is a little bit surprising that they haven't done that already, considering, the virus and stuff with how the world is. Because I really don't know, like, how early we're going to be seeing conferences returning. So
They're
getting those
running it in
trainings,
person in London again in March.
are they? Okay, interesting.
At least
So,
that's what the date says. I mean, obviously, if things get locked down or whatever, but
yeah, I
um,
mean, that seems interesting to me that they would even uh, be willing to risk that and that people would be willing to go to that training, especially with like the travel and stuff is the bigger issue, I think. Like I think isolating at the training wouldn't be too hard, but the travel would suck. So
yeah,
yeah,
looks like
that is
April,
unfortunate
not
they haven't made
March.
it
Sorry.
online. Yeah, okay. That said, we can move on to CMU trying to stop the naming madness with vulnerabilities. So they put out a blog post called Vulnonym. I think that's how you say it. I'm probably not saying it right, whatever.
Yeah, I'm not even going to try.
Exactly.
Vaughn and
Um,
Anonymous. It seems like they're kind of combining those two words, but they also have a Twitter.
yeah. So we've talked and memed a lot about named vulnerabilities over the last while because they've been increasing in popularity as time goes on. And this blog post from Lay Metcalf talks about name vulnerabilities, mentioning some of the points people have brought up before that we've talked about on the podcast. The fact that numbers just aren't super memorable for humans. We like words a lot more than numbers. And so, because of this reason, they're proposing using automatically generated neutral names for vulnerabilities. That way, there's no spooky implications in the name that tries to hint at the impact. They say we plan to name the vulnerabilities with a phrase of adjective nouns, for example, arbitrary albatross. And how they do this is they map CVEs to names through Cantor depairing function, I think they call it. I'm not familiar with enough with like math and all that craziness to know exactly what that does. But if you want to see this in action, you can check out their Twitter that I think Z pulled up. So they have like a bunch of CVEs on there, and I think they put out a tweet that maps a name to it as soon as the CVE is issued. Um, you can tell obviously by the blog post and how the tweets are worded. This isn't serious. It's an ironic take on named vulnerabilities. Like there's
Though,
one tweet,
at the point of recording, the latest name vulnerability is Shapely Monkey.
Shapely Monkey. There we go. I was going to point out another one that I thought was funny was my real name is CVE 2020 11157, but all my friends call me Cloudless Ringtail. I mean, this is a pretty this is a pretty banger post and idea. I really like it.
Yeah, it
But I
definitely
thought we'd throw it in for some fun.
feels a bit tongue in cheek.
Yeah,
Like they kind of present it as though it's serious, but I have to assume that they're more doing it as a tongue in cheek thing rather than uh, a real sense that this is useful.
for sure. But yeah, it's always good to have some fun thrown into the mix, especially in the god awful year that is 2020. So, getting into some serious research, we have DeFuzz, deep learning guided directed fuzzing. So, this is a fuzzing research paper that combines two of the favorite things we cover from academia on this show, deep learning and fuzzing. And we have a guest that's on actually to talk about this topic and to talk about fuzzing from an academia angle in general. We have CTS. Anyone listening from the CTF community may recognize him from Perfect Blue, which is actually ranked number one on CTF time at the moment. Um, so I will mention the name of the paper before introducing him. It is DeFuzz, Deep Learning Guided Directed Fuzzing, and it's a paper by Australian university researchers. So welcome in CTS. I'll let you introduce yourself here and give some background.
Hey, I'm CTS. That's what most people in the CTF community know me by. You might also know me from Twitter, where I post stupid memes about security. Uh, yeah, I'm a researcher, undergraduate at Georgia Tech, and my specialty actually is fuzzing research. So I've been doing fuzzing research for about 2 years, essentially, and I come from like an academic background as well as practical one. So that's why I thought it'd be interesting to join today and discuss this paper. Yeah. Actually, I basically have to read papers all the time. That's like part of my job as an academic researcher. So it's interesting to like actually do a paper review on stream like this. So yeah.
Yeah, it'll be cool. It's definitely awesome we were able to get you on for this. So I think we'll start off with the paper specifically, and then maybe we can move into more of a general discussion around fuzzing in academia.
Sure.
S- So, fuzzing and trying to merge in machine learning or AI has been a combination that people have been thinking about for a while. I remember I think it was the last podcast episode when we talked about GPU based fuzzing. I mentioned one area where you could apply usage of GPUs for fuzzing is using stuff like CUDA cores for machine learning and integrating it that way. And so these researchers proposed DEFuzz, and what they came up with was basically using libtiff, libpng, and ffmpeg, extracting out abstract syntax trees for each function and taking the ones that have had vulnerabilities or CVEs attached to them to train a deep learning model with it. That model is then ran against target software and it's used to determine the locations of most interest for vulnerabilities and then targeting those areas with directed fuzzing. So that's where the DE fuzz comes from, directed fuzzing. For testing, they tested against 8 open source programs. 7 are from the libming library. So they've got list action D, list SWFD, and then a bunch of SWF2, CXX, Perl, PHP, Python, and GitLab. So the experiments were carried out on a Ryzen Threadripper 2990 WX processor with 128 gigs of RAM, and each program was given a single core. So main things that we're looking at for in this paper for evaluation were performance, execution speed, coverage, and bug discovery. And they then benchmarked that against AFL, which is kind of the thing to beat when it comes to fuzzing. So when it came to list action D and list SWFD, the number of bugs found were pretty close. They were 5 for DFuzz and 6 for AFL and list action, and 12 and 14 in the list SWF. So DFuzz did a little bit worse than AFL in that regard. Both times they were getting beaten by AFL there. But when it came to the SWF and GitLab targets, AFL had 0. So figure 4, page 5 shows that the timings were also pretty competitive between the two for time to find bugs. It went toe to toe on most of the programs they tested. In their conclusions, they state DeFuzz can achieve better performance than AFL when it comes to how quickly it finds vulnerabilities, but stated that there's some other directions that should be explored as well. One they mention is addressing the class imbalance problem when using deep learning. So, when it comes to thoughts about this paper, I found it really odd that AFL had 0 findings on some of their targets. It suggests to me that they didn't write a harness for them. because I find it hard to believe that AFL would just not find anything unless you were using it improperly. The target selection is also really odd. I've never seen these targets used in any other fuzzing paper before. They almost seem like they might be cherry picked. Because it's just like, why these programs specifically, right? They don't really seem to give any justification on that. And that's a problem I see in a lot of fuzzing papers is the target selection. Is just like, we choose these targets that nobody ever attacks and we won't say why. And that's kind of what I was thinking in this paper was just why these targets? They don't really make sense to me. I don't know if I don't know if you found anything in the paper that would like indicate their justifications for that,
Well,
but
I think a lot of times the justification does come down to trying to choose something that, or at least a lot of times we tend to see like these parsers chosen, things that work with some sort of file system. Some of that does feel, as you were kind of just saying on the cherry picking side, some of that does feel like it's just being chosen because, okay, it's somewhat of a popular file format, therefore, it's a real library. And we've talked before about benchmarking and like choosing the benchmark binaries there. I do feel like this is kind of a suspicious list. I'm not sure if I'd say they're cherry picking or if there was some other reason to it. The Swift stuff, though, does seem like a really weird choice. I did also find table 3 talk about the detected bug types as being out of memory and double free. Is that all? Like, is that all that's being looked at here?
yeah, that's a very limited selection of bug
Like,
types.
like it feels like that's missing something. I also do agree with you, like where AFL just wasn't getting anything. Feels like something is weird is going on with this paper in that sense. Because I'm not really like, I don't see why AFL would fail, this one wouldn't. It does seem weird though that this one's finding, all the paths that AFL is or more in a lot of these cases, when they're specifically looking at this as from a directed fuzzing perspective, where it's in theory using the deep learning to find where to target the fuzzing and going for those paths specifically. So I would have imagined that this would have resulted in at least some gaps in terms of the coverage where it's not hitting everywhere because it's trying to focus in on some certain paths.
Yeah, it seemed like they were trying to go for like a more surgical approach as opposed to like a broad scanning approach.
Yeah,
So
but
yeah,
the
that is a little
stats
weird.
here don't really agree with that.
Yeah. So CTS, I'll let you give your thoughts here on this research and just fuzzing research in general, if you want to touch on that.
Okay, sure. So I think I have the same concerns as you as the paper for the paper. So I agree that their evaluation is probably kind of weak, especially considering the experiments that they run. So when you publish a paper or when you submit a paper to a conference, one of the things that the reviewers typically attack you for is if your evaluation is like spotty. And a big part of that is if your experiments seem arbitrary and you don't like provide like a justification for that. So like, for example, if you're evaluating your fuzzer, right, you essentially need to provide a strong rationale behind which of the experiments you chose to run, because otherwise you are essentially able to just cherry pick and choose only the cases that highlight the qualities of your work, but not necessarily like the cases where it's the same or not as good as like the existing, right?
I will
And
quickly ask, could you reset your thing because your mic quality
God,
is coming through a bit bad. um, but yeah, I mean, I was kind of thinking along those same lines as well while you're resetting your mic there. Um, So one thing I remember you saying before was basically how fuzzing has kind of hit a point of diminishing returns after AFL. I don't know if do you think that's kind of highlighted in this paper as well, that
can you
angle?
say again? Sorry, my bad.
Yeah, no worries. You were kind of saying before when we talked about how fuzzing has hit a point of diminishing returns after
Mhm.
AFL, and do you think that's kind of being demonstrated here as well?
So this might be a controversial opinion, but I think that there's some sentiment in the fuzzing research community that it's kind of like beating a dead horse almost at this point, because I think that when AFL was introduced, I think that sparked like a wave of new research, and when people were applying AFL to a lot of different problems and adding a lot of interesting extensions to that. For example, there is a lot of good work on like concolic execution or fuzzing different targets, such as like KAFL or syscall for attacking kernels, right? And I think that uh, at this point, I would say that the fuzzing research community has kind of like saturated a lot of the possibilities for what you can do with fuzzing. And I also think that with the increasing adoption in industry, I think that fuzzing is kind of reaching the end game, so to speak, if that makes sense.
Okay. Do you think that this paper's results look
Sorry,
promising for
Spectre.
the?
Can I actually jump in on that opinion? I'm
Yeah,
actually
go ahead.
not sure I'd agree. So you probably have, or you definitely have more experience when it comes to the academic side. That said, I do think there are at least some more practical areas to be explored. When I was reading this paper, I was kind of reminded of the Kobe paper. And that was using directed fuzzing to do automatic exploit generation for kernel out of bound writes. And I did think that's kind of another area that like I guess I think there are more areas that fuzzing can be applied to, like that sort of I mean I say exploit generation. It was basically looking at finding the or expanding the ability of an OB right. So say you only have it, they can get an out of bound right to 2 bytes or something, and it would look at finding different strategies, fuzzing different strategies for maybe getting more bytes written or more control, whatever. It would just fuzz for different strategies. The reason I was reminded of it was because it comes down to being another directed fuzzing paper. But I do feel like there's maybe more room for exploration in that area rather than on just kind of the generalized fuzzing.
Uh, yeah, I think like you obviously fuzzing is just a technique that can be applied to a broad like variety of problem domains, but I think that fuzzing research in itself has become pretty saturated.
Okay, yeah. So keeping it just on like the pure fuzzing research, yeah. I mean, we're getting a ton of papers, and a lot of them do seem a little bit over exaggerated, I guess.
Well, actually, the evaluation of fuzzers is a huge problem in academia right now, in the sense that we have no good way to benchmark fuzzers and compare them to each other. So, for example, like let's say Lava M, for example. Lava M is essentially a set of programs where they added a bunch of bugs, and you compare fuzzers based on how many of the bugs they added to the programs that they find. And actually, a lot of people object to Lava M because they say that this is like a synthetic benchmark, it's a synthetic workload, so it may not necessarily reflect the effectiveness of the fuzzer in real life.
Yeah, I think we talked about Lava M on one of the past episodes when we were also talking about Magma.
Yeah, did you ever take a look at Magma CTS? Did you ever notice it when you were looking through papers in the past?
No, sorry, I don't recall.
Oh,
Okay.
okay, no worries.
Yeah, it's a take kind of like Magma where it's injecting vulnerabilities, but rather than, or sorry, kind of like Lava M where it's injecting, but rather than injecting uh basically injecting the case that needs to be fuzzed and then invoking the crash, it will inject basically forward port vulnerabilities into the most recent releases to kind of create a sort of ground truth.
Yeah, I
Uh,
think that using real world vulnerabilities is actually a much better benchmark for fuzzers. I think some of the best evaluation sections are the ones where they just take like an old version of a program and see if they can find like a CVE or not.
yeah, and I think that's definitely better, or at least a more practical evaluation, because it's at least showing it can do something. Like, and we have actual kind of a ground truth to compare it against.
And this is one problem I have with some fuzzing papers that I've talked about on the podcast, but also just with you as well, CTS, is the fact that a lot of these papers focus a lot on the performance angle. Like, hey, I can generate 6 million test cases per second. That's awesome. But it's also like tertiary in terms of priority.
Hmm.
I feel like there is a huge push on trying to make really fast mutators and generators, and then they just don't even really consider the other bottlenecks or what's actually important, which is can this find issues. I feel like there is a bit of a too much of a shift towards the performance side, and some of the aspect on the practical side is getting lost because of that.
Well, actually, I think that this is simply because of I don't think that there's necessarily been a shift towards favoring performance over coverage. I think that in most papers, coverage is still the king. Well, actually, no, bugs is the king in terms of your evaluation. Like typically, I think as a reviewer reviewing a fuzzing paper, the first thing I look for is can it find like a CVE? If they have like a table of like 30 bugs, then I immediately like this paper because I know it works, right? Because like there are papers that just like don't work, and like that's just a thing, right? So if it can find like bugs, that's great. And then the next best thing would be coverage, because coverage usually is correlated with bugs, but not in all cases. But I would say that finding coverage is a very important part of the fuzzer, right? So I would also compare coverage. And I think that performance is only a tertiary thing that I don't really consider uh, much at all, actually. When I'm reading a fuzzing paper, I don't really care about their performance at all. I think the reason that they include performance in papers that do heavy stuff like machine learning or like symbolic execution is because these tools usually have a stigma around them in the academic community that they're very heavyweight, and then thus can seriously degrade the fuzzing performance because they're so heavy. So I think that they probably included the speed in the evaluation as kind of like a defense mechanism for their paper to defend against any criticisms that like, hey, you're using such a heavy technique, could this negatively impact the fuzzing performance?
Okay.
Uh,
So another thing that a mutual friend of ours said in a similar discussion was the fact that it seems like fuzzing is overshadowing other areas of promise in academia. So like, static analysis, manual code review techniques, stuff like that. Do you think you'd agree with that sentiment that fuzzing is almost problematic in the way that it's taken over everything else and those other areas are getting neglected?
well, you could say the same thing about machine learning, and like you could say the same thing about machine learning with like deep learning for image recognition versus classical computer vision algorithms. Like, has machine learning overshadowed the CV community? You could argue yes, but then you could also argue that like, well, machine learning works, so maybe we should focus on that. And at the same time, I also think there's kind of a meta problem to it, because fuzzing papers are kind of like really well optimized for academia, because it's like you can have an idea and then you can implement the idea for like the fuzzer, and then you can just test it and make the coverage graph and submit it to a top conference and get it accepted. So in that sense, it's kind of like a paper template that just like works really well for academia, and that's why it's so popular, because it gets accepted to conferences. And I would say the same thing about like machine learning too. It's like, okay, well, I have an idea on how to improve the architecture of the network, so I'm going to implement that. Then I'm going to evaluate it. I'm going to give the graphs, and I'm going to make like a fancy diagram, and then I'll submit it to conference, and it'll get accepted, right? And as opposed to another thing like static analysis tools or like code review tools, these things are extremely hard to evaluate, or it's not as easy to evaluate as a fuzzer, because when you evaluate a fuzzer, all you have to do is just show the coverage improvement graph, and you're like, oh hey, our fuzzer beats AFL, let's submit it, right? But if you're evaluating a tool that helps people review code, like how do you quantify how good your tool is, right? So that already makes it much harder to write a paper about it. So that's another reason why I think fuzzing is really popular, because it's just a format that works really well in academia. And it's very cynical. That's a very cynical perspective, but I think it's part of it.
It's perhaps cynical, but it completely makes sense in terms of kind of having that end game as being recognized, by being accepted into the conferences published there. Oh, or published with the proceedings and all of that. Oh, no, I makes sense. I haven't really put much thought into that aspect of things. It's not really my area, but I mean, even if it's cynical, I don't see why it wouldn't be the case.
Um, I guess one other part of the paper I wanted to highlight was that the deep learning aspect. So I've actually read 3 or 4 like deep learning papers about fuzzing, and none of them worked up until this one. But then again, I don't know if they cherry picked the evaluation or it really does work for this one. But anyways, the main issue with machine learning for fuzzing is that it just seems to not work. The past 3 papers I read, they tried to jam machine learning into AFL at the actual mutator stage. But in this one, I think it's very interesting the approach they take, because they're using machine learning to essentially pre-compute locations that they think are interesting and then guide the fuzzer towards that. I think that's a better approach than the previous machine learning fuzzing ideas. However, the main aspect of this paper that I'm concerned about is that it may not necessarily, like machine learning may not necessarily be able to identify bugs as accurately as they may purport it to do so. Like, machine learning is a great tool, but I don't think it's a silver bullet that you can just throw machine learning at the problem of finding the bugs and then it will find the bugs. Like, I don't think that's necessarily true, because I think that even if humans still have a hard time finding the bugs, and programs can be so complicated and bugs can also be very complicated, then I think it is not necessarily true that machine learning can just magically find the bugs, right? I think maybe machine learning can find very obvious bugs like integer truncation or integer overflow, but I think that a human reading that code with maybe some like linting could also find that as well. So that's another big aspect I'm concerned about this paper. And I think their evaluation does not necessarily prove that machine learning can find bugs, which is essentially like the linchpin of their paper, right? If you do not have the assumption that machine learning can find the bugs, then this paper, the argument doesn't hold. And they don't show in their evaluation necessarily that machine learning can find the bugs. All they show is a few anecdotal examples of when machine learning found locations of bugs that were close to what the fuzzer found. But this does not mean that machine learning can find bugs in general.
That's a fair point.
I mean, on that point, I also have a few like concerns that I just thought of. One of which is they're training the models on these programs that they mentioned. You know, like the list action and the lib SWF stuff. I wonder how well that actually transfers outside of the more file format oriented stuff. Like if you take this to, let's say, a browser, I feel like you lose a lot of that transferability. The other problem is it seems like they're manually training the model, because they talked about looking for CVEs and attaching them to functions that are broken out into ASTs, and it's like I don't think they mentioned that they have an automated tool to do that. I think they're doing that manually, which seems like it would be a lot of manual overhead to train that model. Um, which, when you put it into like a practical situation, I could see why people would just not want to bother with how much manual overhead is involved with that. But that's just like my initial thought. I don't know if that would actually translate into the real world, but that's just something I was thinking of while you were talking about it there.
Actually, I would love to comment on that because that's a huge problem with academia versus industry. So there's a huge problem of transferring academic research that's conducted in the bubble of academia to in practice in the industry. Because what you don't see in a paper is essentially all the legwork that the grad students did when they made the thing for the paper. So when you write the paper, like when you make a project in academia, you kind of make it backwards, right? The most effective strategy I found personally for doing research in academia is I first imagine what the paper will look like after it's written, and then I kind of like build the project to fit the paper, if that makes sense. Okay. Uh, Obviously, the correct way to do science is you do the project, then you do the paper because your project is just so awesome that it deserves a paper. But in the real world, you need to publish, or else you're not going to graduate from grad school. So you need to basically imagine what kind of thing that you would like to, what kind of paper you would like to write, and then you'll make the project to match the paper. So the thing is that most good projects require a lot of engineering work. However, in academia, most of the projects are kind of, you just kind of hack that together and then you just write the paper. And as soon as the paper and evaluation is done, you just like do not ever touch that code again. And hopefully no one will ask you to maintain it and stuff like that. You know what I'm saying? So a lot of the times when you try to re-implement the paper,
Yeah, no worries. CTS is just going to fix his mic. But I will kind of augment that by saying I've noticed that with fuzzing stuff we've covered on the podcast before is we've looked at some promising projects. Like one, what was that Linux kernel one, Z? The one that did the automated data structure extraction?
Data structure.
For some reason, I can't remember the name
Well,
of it.
so I know I don't think we've talked about it too much on the podcast, but DeFuzz was doing that with the Linux, or
Right,
sorry,
that's
with
what I was thinking
Android
of.
kernel. There's one that reminded us of DeFuzz, and I can't recall what it was called.
Okay. But like one thing I've noticed with projects like DeFuzz is the paper is out, it looks cool. They have their source code on GitHub or something. And then you go there and there's been no commits in multiple years. It's just totally unmaintained. It's basically unusable because the tool chain for whatever the target was has moved on. Like that is that is something I wanted to touch on that you kind of brought up, CTS, was the fact that often these projects unfortunately get abandoned and don't really go anywhere. And then if somebody finds it and finds it interesting, they can't get it to work, or they have to put in so much time and effort to get it to work that they just don't bother.
Well, this will be extremely cynical coming from me, but sometimes, as researchers, we really hope that nobody tries to make it work, because then they might not realize that it's not as glamorous as the paper sells it to be. This is very cynical, but I feel like it is the truth that nobody wants to talk about.
Fair enough. I mean, it kind of makes
Yeah,
sense.
that's like, since we're talking about DeFuzz, like I spent some time this summer I basically ended up re-implementing it because I
Well,
like the idea, but building
I
it
think
was. Go ahead.
So I think one misconception that people have when they are trying to use work that was made in academia, they assume that the source code is what is on GitHub. So that's actually a misconception. The source code is the source code is the paper. You should think of the GitHub as a reference implementation that you double check yours against when you're confused when you're reading the paper. The authors essentially pretty much expect you to read the paper and re-implement it yourself and then double check against theirs. That's why that's the less cynical explanation for why the source code doesn't work, is because they didn't expect your use case. They expected you to re-implement the paper for your use case, if that makes sense. Uh, I think the main difference between academia and industry is in academia, you're kind of the value of the work is the idea, whereas in industry, the value of the work is the result, if that makes sense.
Yeah.
Yeah, I guess that does make sense, and actually, what then explain kind of my issue. I was dealing with something GitHub code.
So one final thing I wanted to ask was, do you like do you think these results look promising enough to justify like looking into this path further, or do you think it's just not worth trying to integrate machine learning in this manner? I know you touched on it a little bit earlier, but I just wanted to get like a kind of like a concrete conclusion, I guess.
Okay, so my gut feeling reading this paper is no. I don't. Okay, so the first thing that stood out to me is the paper is very short. Most fuzzing papers are about 13 to 18 pages long, and this one is only 8 pages, and like one page of that is related work. And I think there's also like references like that. So the paper is very short, and that's very concerning to me. There's not much substance to the paper, which is also kind of concerning to me. And the evaluation, like we already discussed, is pretty spotty. Uh, I think that this general direction may have some potential, but I don't think this specific paper is like super promising. So I wouldn't like spend my time trying to re-implement this if I was, say, working at Google and I was trying to improve their like fuzzing cluster, right? I think it's like a good first step towards applying machine learning in a realistic way towards fuzzing, but I think that the practical result is just not great.
Okay, cool. Um, so I think that'll probably wrap up the discussion on DeFuzz. We appreciate you coming on, CTS. If you're up for it, we can probably have you back on again sometime for future topics. If you'd want to give your thoughts on, we'd be happy to have you again. I don't know if you're gonna hang out for a little bit while we cover some of the other topics. You're free to if you'd like. But yeah, we're gonna move on to our second research bit, which was from Sammy Kamkar. So Sammy Kamkar announced a new attack last week on Halloween for bypassing network address translation firewalls, which allowed you to access any TCP or UDP service on a victim machine. He calls this technique slipstreaming. So Z, I'll let you cover this because I will say like this is a topic that it's a pretty complex attack, and it's an area that I don't have a lot of knowledge in the area of like networking and network security. So, and Z, I know you have a little bit more experience than I do, so I'll let you you hit this one
Uh,
off.
I have a bit more, but I think this attack can kind of be broken down into at least a somewhat simpler idea, where at its core, what you're doing is, like, I feel like this high level overview just jumped way too far into the weeds.
I was thinking that too.
So stepping back on that, there's a lot of steps about exposing somebody's internal IP, talks about how he does that. But the key things here are, actually, I guess I should say what this allows you to do. The idea here is that you trick an application layer gateway into basically opening up a connection to you, or allowing you to connect in on whatever port. Like, it'll open the port for you so you connect to services on the internal network. So the way it does that is this application layer gateway, reads the packets and looks for a certain request, does some connection tracking to try and figure out, hey, am I likely to get a response from the remote host, and from this packet, if you're sending like UDP. If so, it's going to track things. So the trick here is that it figures out what in one case, it figures out what the maximum transmission unit is, the MTU, figures out basically your max size, so where the packet's going to get fragmented. And then you craft a packet that you're going to send from the user's browser that is basically just over that maximum size, so that the packet gets fragmented, and the second packet going through looks like something else. It looks like, in this case, they make it look like a SIP packet, or SIP. Which is it's one of the VoIP protocols. Kind of looks sort of like HTTP, but completely different also. But it's a line-based one. So basically, by using that fragmentation, when that second packet goes through, if the application layer gateway just looks at that second packet and just sees, hey, this is a SIP packet. Oh, I need a be aware for a response, or need to forward this port because of it. It's just going to do that because it sees this single packet that looks appropriate, and it's ignoring everything else that was part of the first half of the packet before the fragment was hit. So that's kind of the gist of where the issue comes in, is by causing the packet to get fragmented, by causing it to get split, you get that second packet looking like some other type of data that the application layer gateway just doesn't really. This does depend on having some sort of bug where either the NAT isn't going to combine the packets coming in before it hits the application layer gateway, or the gateway not checking the fragment offset, at least in terms of, or at least on the IP header, it should have the fragment offset, but that isn't true for the TCP version of the attack. But kind of the gist of it is you need some bug existing at that layer, which may or may not be the case. This used a older Netgear router. Yeah, Netgear Nighthawk R7000. Which used, actually, I guess I'm not sure how old that is, but the kernel here was like 2 point something.
Yeah, it was from like early 2000s kernel version, I believe.
Yeah. Maybe 2.6 I'm seeing here.
So the way you explained that, with the way that fragmentation works and how the attack works, it reminds me of HTTP desync attacks, actually, which we talk about fairly frequently on the podcast. That idea of splitting a packet and making that second packet being read as something it's not. So when you were saying that, it made me think a lot of the HTTP desync attacks, where you use a header to inject into the next request, right? I don't know if that's like a fair comparison, but I just I thought that was kind of an interesting thing that I thought of while you were talking about it.
I think you could definitely compare it with that, and I'd recommend, if you want to know more of the details about this, to read the paper or read the article or write-up here, because it does go a lot more into the specifics of how they figure out where to fragment and how the fragmentation actually works. Like, I've just kind of given this higher level rough overview of it. I've definitely skipped out on some of the details because it is a technical attack that basically just lets you get around the firewall, assuming you've got a system vulnerable. And to be fair, I've asked around a little bit, and nobody I know of has managed to actually reproduce this. That doesn't mean nobody's done it. Just that they haven't been able to reproduce it on the routers that we happen to have.
Okay. So one thing I will say about, like, with you saying people should check it out if they're more interested, there is a high barrier of entry to be able to read this, I think. And a lot of that stems from the fact that there's a lot of three-letter acronyms used. I hate TLAs, but in networking, they're everywhere. So that's nothing against the article author. TLAs are just an unfortunate reality of the networking area, and one of the reasons why I'm not a big fan. You'll have to understand the intricacies of application level gateways, NATs, all that stuff. So there is definitely a high barrier to be able to read this. But I will say one thing I found interesting from the technical details was, in order to pull off the attack, they had to extract an internal IP. And how they did this depended on the browser. So I think, like, Chrome divulged the IP over WebRTC, the WebRTC data channel over HTTPS. But when they couldn't use WebRTC for that, they performed a web-based TCP timing attack using image tags. So in the page, there's hidden image tags to all the common router gateways, like 192.168.0.1, for example. And they attach on error and on success events to those tags, and using the timings of the response on those events, you can determine valid subnets. So if it fires within a few seconds without timing out, for example, and then if the response is really quick, you likely found an internal IP. So I thought that was kind of interesting because you could basically use that to build a browser-based scanner that uses that attack. So I thought that was kind of cool. It seems like something that could be pulled out and used in other contexts outside of just this attack. Yeah, that was like my big takeaway from it that I liked. A lot of the other stuff was, honestly, it was just a little bit over my head because I'm just not in the networking area.
Yeah, fair enough. I don't think that timing attack is actually too novel. I'm not sure about being specific for doing the gateway, but I do know, like, that idea of using image tags to see if a domain or IP exists has been done before. That's why I didn't focus on it too much.
Yeah, I think you're right. I don't think it's like new, but it was new to me, and this article is what brought that to my attention. So
Yeah, no, and it's a great use case for it too.
yeah. So with that said, we'll jump into some exploits. So GitLab had another CVE that was published. This GitLab write-up was published yesterday, though the report was filed on the HackerOne in June. It's an issue in their OpenID Connect identity provider, which facilitates the ability to authorize services to use your GitLab account and operate it on your behalf. So the issue is, once you grant an application access, a bit of background. Once you grant an application access to your account, you can revoke it at a later time through your profile settings. The problem is the code that the provider gives the third-party service doesn't expire or get canceled after the access is revoked. So, and that code can be used to retrieve access tokens and ID tokens. And the application also reappears in the authorized application when those tokens are refetched, and all the previous permissions are restored to it. So basically, it just seems like they weren't invalidating the access codes after access was revoked. So this could basically be used to maintain persistent access to an account, because every time access gets revoked, the third party can just ask for a new token and get the access restored. Um, this does require you to initially allow access for that said third party, obviously, and typically you should be very careful when you grant access to any of your account features and who you grant access to, regardless. So the impact is a little bit limited there. You would have to grant access to a malicious third party that's looking to abuse this bug.
Although one thing is, like, if you're already compromised, this would be like a persistent backdoor into the GitLab. You would just, like, if you were to already compromise an account, you go through this process, and then you can kind of keep recovering access, at least API access, through this vulnerability, which it does seem like a significant issue to me. I do agree, like, on it's not something that's going to be like widely effective. You're generally not going to be connecting to too many random, especially rogue service providers. So like that in itself does lower the risk. But I would say that this still like has its use in terms of if you want to persist access after you had already compromised the account.
Yeah, and they do mention that there are some GDPR concerns. I think they point that out in the last paragraph. The fact that you've revoked access, but other companies can still potentially have access to that data. So that is a valid concern. The European GDPR. In
Well,
terms
it
of
seems like that's the only reason GitLab even patched it was because of the GDPR.
yeah,
Because they do mention here they reported this in June, but it was also marked as a duplicate of a report that was at least 2 years old. July
yeah,
17th, its report is immediately closed as duplicate. At this point, no invite to the original one. He added the GDPR on the 20th of July. He added that GDPR point to the report. And then 2 days later, he got invited to the original report, and on the 5th of August, there was a security release fixing it. So they sat on it for 2 years and only fixed it when they were pointed out that, hey, GDPR says that when consent's revoked, you shouldn't be able to access the data anymore, so this is a violation of that.
worried they were going to get tattled on.
Yeah, I mean, they should have fixed this without needing that point. Like I kind of mentioned, there's a real use for this, even if it's not the highest risk. It's clearly an issue.
It's kind of interesting, right? Because we've covered quite a few GitLab issues before, and it's generally been like pretty positive on GitLab's side. They have a quick turnaround. They don't try to wiggle out of not fixing issues. But in this case, it just seems like the timeline indicates, yeah, they really just didn't want to be bothered with fixing it for whatever reason. Um, and there's another weird thing. The article has a link saying the GitLab issue becomes public on the 29th of October, but that link goes to a 404 page. So I don't know if GitLab removed it or maybe if they just had a bad link. That's in their timeline. I think it's the uh, yeah, 29th of
Yeah, I
October,
just
GitLab issue
tried
becomes
it.
public. Yeah, so it seems really weird that GitLab would either take down that page or that the link would be broken, but that's neither here nor there. Yeah, the timeline here is definitely really weird. And like you were saying, persistent access to an account is pretty serious, even though it is pretty unlikely that you would get hit with this. Still should have been fixed, absolutely. So, Roku. So, getting into the IoT world a bit, we have Roku sticks. Quick shout, I love Roku. It's an awesome device. I use one. But in the next few minutes, we're going to be talking about how their devices got popped, kind of, due to their external control protocol feature. So this feature allows Rokus to be controlled over the local network via REST API. So it's used for like the mobile application and whatever else you want to use to control the Roku with. But there's no authentication mechanism on it. I guess because they figure it's on the local network. It's doesn't need authentication, which I would personally disagree with. But basically, yeah, no authentication. So anyone on the local network can send commands to the ECP port, which is 8060, to interact with the Roku. And one of the things that this protocol allows you to do is install applications. So a local attacker could install applications on your Roku. And the scenario they give here would be malvertising. Because RCE wouldn't really be worth it. Like, what do you gain by RCEing a Roku? Not much. So using a screensaver app is an example they give, and using that to show ads. Now, while this is interesting behavior, and ultimately this comes down to there just being no auth on ECP, which, like I said before, there probably should be. I disagree with the author a little bit when it comes to the presumed impact and the conclusions. Like one thing they mentioned they're not going to release the POC, the source code, because they don't want it being used by script kiddies or something. And one of the conclusions they have is I really think this attack is not only theoretical, but really is a practical one. I mean, local network access is a big ask, and all you're getting with it is the ability to show advertisements. I can't really think of a scenario where you could even hit this on like a public network or something, because it's not like McDonald's or Tim Hortons is going to have Roku's running on them. So it seems like this might be useful for like pranks and not really much else. I don't know if you agree with me on that, Z. Maybe I missed something, but this does seem like it's blowing the issue a little bit out of proportion. But Z, I think you're muted still, by the way, if you were unaware.
Yes. I do think that, like, they do talk about how to discover the Roku kind of from a browser. Like, they do toss a little bit towards that. You could even do the timing attack we were just talking about with the NAT streamlining, or slipstreaming, sorry. With that one, you could maybe do that to try and discover the Roku. So like, you can pull this out from a browser. You can get a pretty wide hit on that, like, and the advertising that way, like injecting the ads, really wouldn't be that, or it could be somewhat profitable. So I don't know. I mean, I
Maybe.
don't feel like he's overplaying it, just because I will pull attention. This is adtechmadness.wordpress.com. Like, this is his thing. Like, that's what he's talking about, is like the ad tech and all of that. So like, I don't feel like he's overplaying it by spinning it towards his own audience.
Yeah, I mean that's fair. I think we can move on to Tiki Wiki. So Tiki Wiki, this is a quick one. It's a login bypass, and the method of how it works is extremely strange. I'll just quickly go through the walkthrough that they provide. So first, when TikiWiki is installed, an admin user is created, and the provpass, presumably provided password is what I think it stands for, is created. And so if you try to log into that admin account after 15 login attempts, so if you try to like brute force it, the server stops expecting or saying that the password is wrong, and it says that the mail can't be sent, which seems odd. I guess they're trying to send emails to the email attached to the admin account on failed login attempts, and after 15, for whatever reason, it can't send anymore. But then after 50 attempts, the account gets locked. And it seems the way that they lock the account is they set the password to a blank password. So after you send 50 failed login requests, you can just send number 51 with a blank password. Just send a login request with the password stripped out, and you can log in. Now, this is really strange
Well,
that
it's
it
not
works
quite you
this
can
way.
log in. I do think it's important to point out that you're brought to the password reset page.
Okay, yeah, sorry,
Or
that is a point I was
am
leaving
I
out.
actually, maybe I'm mistaken about that.
I think you can
I
switch the password once you're in, but I think it does uh, grant you login access and
Yeah, no,
bypass login
actually, I
entirely.
think I am just mistaken about that.
Yeah,
So
I
I'm
think it's
coming in
just
to point something out that doesn't matter.
I think they do mention that that is a possibility, but that's not like the initial foothold.
Yeah, so I do agree with you, though. It is a weird scenario where you brute force, you get the account locked, and then if you don't provide the password, it'll log you in. It does, like, I'm having trouble imagining the code that results in this. And I do think this is actually open source, so I could have looked into it. But like, I have trouble even imagining how you would do this. Like, how you would write this code that results in this sort of issue.
Yeah,
Like,
my guess is they were just trying to figure out how do we disable the account, and instead of wanting to add another flag into the database or whatever, they were just like, oh, let's just set a blank password. Nobody can enter a blank password.
well, they
Without
don't
thinking that you could just
change.
use the raw request, right?
Well, so it's this, because they do have the hash and they have the prov pass. I would assume that part of the password is the hash itself, because that looks like a password hashing mechanism. Like, that looks like that. Well, that looks like a crypt hash that they're showing. So I would assume that that's more where the password is. So when it gets locked, you get something in this profpass value. And I just don't know what profpass is doing or should be doing.
Yeah, the details are a little bit lacking there, unfortunately. Yeah, it's a really strange issue. But yeah, just a quick one. Getting into
Oh, go ahead. We'll move on.
all right. Getting into a more meta exploit. Sorry for the pun. I do feel bad. We have a Metasploit framework template command injection. So this is a command injection in the framework's Venom tool, which is used for payload generation. It exists in the ability to use crafted APK files as an Android payload template. So for those not familiar with Android, APK is the app installation packages. So when parsing the APK file, it tries to extract the owner and timestamp from the signature, and it then uses those details to generate a new signing key and generate a certificate using KeyTool. But when parsing the owner string from the original APK, it's passed to open3.popen3, which is a Ruby function, as a single parameter. And this Ruby function is basically like a wrapper that wraps around system while opening std in, std out, and the std error streams. So it's a very dangerous function. And the fact that it's being passed as just a single parameter and it's not being parameterized means that you can just use a single quote to escape it and inject shell commands. It's a straight up, just fairly straightforward command injection. And as such, the fix for it was also pretty straightforward. Just parameterize the arguments. The best part of this advisory, though, I think, is one paragraph. They said, to make matters more confusing, there is now a Metasploit module that exploits this vulnerability. Thus, there could be a scenario in which a user of Metasploit uses it to attack another user using Metasploit. This is like meta to the next level, using Metasploit to hit another user of Metasploit. This is just off the charts, I think. So
Yeah,
yeah.
at the same time, like, this is one of those issues. It's fun. It's a fun issue, when you're attacking the attacker's tools. Those are always those fun issues, but realistically, you probably shouldn't be using, these random APKs you find as your
No.
payload. Like, you just shouldn't be doing that. Like, as a pen tester, presumably doing some assessment, you shouldn't be trying to run code that you don't completely trust on a client. So, I mean, technically speaking, they're the victim, but you're doing a pen test, you're hired. You're not supposed to be doing anything malicious. You don't want to accidentally upload something malicious onto a client either, or onto one of the client's employees. And I mean, if you're being a black hat, you still probably don't want to do that. But that gets more into, like, you're probably going to try for persistence and bot killing and things like that when you're installing your own botnet. So, I mean, the risk of this one does feel kind of low, but it's still a fun issue. It is there. It is some that could be taken advantage of, especially toss on a little bit of social engineering. Like, I could imagine a ton of people falling for this if they're just following a tutorial and then it's like, oh yeah, and do this file. And then kind of they're popping everybody there.
Yeah, I was gonna say it kind of falls into that category of just don't run scripts you don't know what they do, and similarly here, don't run payloads that you don't know what they do.
Yeah, definitely. It's the same idea.
Yeah. All right. So next, we will move on to our game exploit of the episode. This was a blog post from Secret Club about a wormable RCE in Alien Swarm, which was a game released in 2010. And it comes down to an arbitrary file write via client to and from server file upload. So that's pretty big deal. It's not just an arbitrary file write from client to server. It's from client to server and from server to client. So the issue is here, they allow the uploading of I think it's like these weird configuration files. But the problem there is they don't actually check the file extension on the server side. They only check it on the client side. So, going from client to server, you basically have an arbitrary file write for free. But even the checks that are in the client side aren't very good, which I'll get into now. So server to client is a viable attack because those checks have flaws. they check for things like dots and slashes to try to prevent directory traversal. The problem is dots can just be ignored if you use an absolute path, and the slashes can be escaped using a backslash because the escapes aren't evaluated and stripped out until after the validation occurs, not before.
Yeah, and
So that ordering is like a big problem there.
I'll say kind of one of the common things we've seen plenty of directory traversals. Just resolve any path you get in any file name to its canonical path, and then just look at the prefix. It genuinely is that simple to figure out if it's breaking out. Don't try finding the breakouts, or in this case, like blacklisting things, because blacklist, we even kind of mentioned it earlier in the stream, but blacklisting can still have bypasses, whereas if you just do that, there still might be some bypasses on it, but it's going to be a lot less likely when you're dealing with the canonical path.
Yeah. So that gives you the ability to directory traversal because of that bad validation. And then the extension check is also bad. How they try to do the extension check is they ensure that the file given doesn't end with a .dll or .cfg, but the check is done on a 260 byte user provided buffer. But when it's actually used, it's truncated to 256 bytes. So that a buffer size discrepancy means if you just fill up the path of what you want up to 256 bytes, and then add a valid extension or something that won't fail any checks for the last 4 bytes, you can just bypass that check because those last 4 bytes aren't going to be used anyway. So by abusing this exploit twice, you can essentially plant a DLL on a system and smash the config file to load that DLL via the plugin load functionality. Because this exploit allows an attacker to infect a server and can conversely exploit this bug in the reverse on clients, that's where the Wormable part of the title comes into play. So yeah, not every day you see a Wormable game exploit. We've covered some RCEs in games in the past, but nothing like this, I don't think, that I can remember. So this issue was reported in May, and it was fixed in August, and that kind of highlights just how serious of an issue this was, because that is a very quick turnaround time, especially for Valve. Um, Valve Valve is infamous for taking an extreme amount of time to do anything, whether it fix security issues or add updates to games. I mean, there's literally the Valve time meme, and I know some people who have had reports for Valve sitting in limbo for months, um, close to like a year. But I guess where this was a wormable issue and it involved the server RCE, it kind of had to be taken more seriously, and they couldn't really dawdle around on it. Um, but one thing I'll note here is this is not something that affects all Valve games. I saw some people asking about that, saying, does this affect TF2 and CS:GO and stuff like that? No, it's specific to Alien Swarm. But still, like this is a pretty impactful issue, and I think it's the most impactful game issue we've covered on the podcast.
Yeah, I think it is. It is like you're talking about how fast the response time was, but that's still like around that 90-day point. That's not a very quick turnaround, I think, in a lot of cases.
In most cases, I'd agree with you, but when it comes to Valve, they're just so they just take so long to do anything that 3 months really surprised me. I was like, wow, that's crazy. Because like I said, like I've known people who have reported stuff through their HackerOne, and it's just so stupid the amount of time it takes for them to resolve those issues.
Yeah, although this is, I guess, it's a 10-year-old game.
Yeah, I think it was released in 2010.
So I guess I shouldn't be surprised, but it does seem a little bit surprising that they're still maintaining it. But I guess there are other games that Valve maintains, yeah, from back then, like some of the earlier CS games, I think.
Yeah, I mean CS:GO I think was 2012. So
Oh, okay.
yeah, pretty old game by now. So we'll move into Pulse Connect Secure, which was an RCE via uncontrolled Gzip extension. So this is through an admin functionality, which allows admins to import and export configurations. So obviously that means this issue is an admin to RCE escalation, not an unprivileged to RCE escalation. So the impact is a little bit limited there. But basically, these configurations are compressed using Gzip and encrypted with hard-coded key. And the problem is they unpack this archive in the home/runtime directory or home runtime temp, depending on the version. and there's no restrictions on what files are extracted. It'll just extract the files and overwrite any files in its path. And the article goes into how this can be abused for achieving code execution. So the first path they mention is the watchdog configuration overwrite, which also resolves in the home runtime path. And it's the home runtime kwatchdog watchdog.conf. And this configuration file contains a test binary directive, which allows you to specify a binary that gets ran as a root. So you can see why that is an issue. The second path they mentioned is PostgreSQL, also a configuration file, just using a different option. This one is the shared preload libraries option. The third one is for use in newer versions, which is restricted to the temporary directory. And this path abuses the fact that the Pulse Connect secure system uses the Perl template toolkit to compile and render templates. So these compiled templates are put in that temporary directory that gets extracted to, and you can abuse that to basically run any Perl code that you want by using one of the templates that gets loaded when you use the control panel. So yeah, 3 different paths to exploit the issue, but the issue basically boils down to don't just extract zip files into a directory without knowing what's actually in them and doing any checks on what's actually in them, because that's nothing really new, right? We've seen unzip type attacks before.
Yeah, we've definitely seen them before, and I mean, the better route would have been to extract this into its own directory, then maybe do some validation to make sure like this actually came from a trusted source. Like there are take some other steps to validate what came in and then restore it. Though at the same time, it is an admin privilege. So when you come in as an admin, I mean, the restrictions are kind of less. I would wonder if there are other places where you can just directly execute code also, just given the type of application that is. Like, I could imagine there are other avenues an admin can do. I don't know what any of them are, but this might not be all that useful if there are more direct routes.
Yeah. So in terms of timeline, this issue was reported June 2nd, and the fix shipped October 22nd. So a bit of a slow turnaround there, but kind of a low impact issue. So I can kind of be a little bit more forgiving on that. Um, I like this article though because I can definitely see how people would think just extracting files from a potentially malicious zip or whatever could be fine without considering the implications of not doing any of that checking. Like we said, it has shown up before. It's nothing new, but I feel like it is something that people don't consider for whatever reason. And this kind of brings some awareness to that issue. So Ubuntu Desktop. We have a story of 3 CVEs in Ubuntu Desktop. So these were found by Vaisha Bernard, and their target was the system bus, which is used for interprocess communication and remote process communication between processes. This is called the D bus or the desktop bus. And this bus on Ubuntu is protected by Policy Kit to ensure that the user has permission to perform whatever action they want to perform over IPC. So one example they gave was like mounting a drive. When you attempt to mount a drive, an authentication prompt is shown to ensure that you actually have permission to be able to do that. Um, but the author wanted to focus on what you could hit that was reachable from an unauthenticated context. So they ended up finding 3 issues that were reachable over the dbus in Ubuntu Desktop. The first issue is in the app daemon, which is a Python-based service for allowing non-root users to do package management tasks. Not a super high impact issue, but this one is basically an information disclosure. One of the things this daemon allows you to do is specify a .deb file to install, which makes sense. Installing packages is one of the main things that you want to do with a package manager. So the install file method creates a transaction object that gets sent over the dbus to facilitate the running of that package or simulating it, but they say that doesn't really seem to do anything, so that's neither here nor there. Um, but something they discovered was they were able to set properties on that dbus interface, and one of those properties was the locale. And that locale is used by the daemon to attempt to read a .mo local file from the system, And you could influence the path that it gets read from by changing that locale. So one example they gave is if you set that locale to /temp.bb, they could get it to read from /temp lc messages appdaemon.mo. Now, this on its own doesn't give you very much, but by changing the directory to one you can influence, you can create a symlink and use it to try to read other files, because obviously the temp directory is readable by everyone, right? So unlike what you may be thinking with a symlink arbitrary file read, this one doesn't like allow you to be able to read the file contents or anything like that, but it does allow you to check if it is a valid.mo file. So you can use it as a side channel to see if the file exists or not by checking the error return, because you'll get a bad magic number if the file does exist. So not a super critical attack, but I could see some situations where it might be useful for probing information about the layout of the file system.
Yeah, not critical, but I definitely think, like, I think it's an interesting approach to leak some information. Like, I like it. I do like this attack just because, I don't know, it's pulling out, I mean, like I said, it's not critical. It's not information that's usually really going to break the system. Like, you're not able to read the information, but I do just kind of, I don't know, have, I guess, a bit of an affinity towards this because it is a cool little side channel, I guess. Using that error message to figure out what files exist. I can't think of too many scenarios where that's going to be super useful. I guess it depends on what type of access you have. You can maybe use it to probe some usernames, like if there's home directories. But anything you do with this, like, you're almost certainly going to need, you're going to need more. You're going to need some other exploit. And I can't think of too many scenarios where you just need, like, to know if a file exists versus needing to know content out of it. Like,
It does
it's
have that
still
cool
an issue,
weird factor
but
though with the side channel.
yeah, like, I definitely, like I said, I like it. It's kind of neat.
Yeah.
I'm struggling to come up with a good exploit scenario.
Yeah. The second issue is very similar to the first one. It's just another side channel to check if a file exists. This one is a little bit more serious because it allows you to get the MIME type of the file. So this one is in package kit. When using basically the exact same trick, an error message is shown saying the MIME type and whatever the MIME type is not supported. But yeah, basically another information disclosure doesn't allow you to read the file contents, but it does allow you to get the type of the files. So that could be a little bit more useful for doing reconnaissance on a system. The third set of issues, though, is definitely the most impactful. It's a denial of service best case or a privilege escalation worst case, and this is through the Blue Man Bluetooth manager. So the DOS is due to the ability to pass arguments into the IP command that gets ran by the Bluetooth manager. So the IP command gets invoked with a hard-coded set of arguments for the first three arguments being link set dev, and then a last hard-coded argument of up, presumably to allow you to pass a string for the device name in. Now they allow you to inject arguments into the string mid-string, but the problem is they allow spaces as well, and they don't like isolate those parameters. So you can inject arguments into the middle of the string. There is a 15 character limit, and it's picky about how it parses the arguments. With DHC DH client, they ended up trying to make it execute a script file, but it didn't work because it was parsed as a single flag when they tried to pass named arguments. But you can inject non-named arguments like ends33 down alias, for example, which will bring the interface down and it will alias down to up. So this provides a DOS primitive. They did have to shorten that because that doesn't go past the 15 character limit, but they just made it so it's ends33 down AL, which is short for alias. So
Yeah,
that's the DOS primitive.
I do want to shout out that they actually do something kind of right in terms of how they also handle the execution here. So when sending the argument, one of the big issues is, like, you know, using like the single quote as we saw in one of the previous articles to break out of the command, and then kind of doing your own shell commands. You couldn't do that with this. They did actually properly do it. So they were sending like this value that we got from the user is the argument, and it's sent in as the argument. So that's why Spectre was saying it includes spaces and all of that. Like it'll include a dash something space follow-up word rather than breaking that follow-up word into another argument. Oh, it included that as just like the singular argument. So it's kind of like a parameterized execution call. So like that was done appropriately. And then in particular, in this case, the script file they were able to use. They were still able to kind of take advantage of that and take advantage of less strict parsing in one of the other possible binaries that gets called. But I did just want to point out that they were actually doing this kind of correctly. It just happened to be that they didn't validate that. They didn't try to inject another argument.
Yeah. So the more interesting problem is when DHCPD is used instead of DH client, and that allows them to pass the script file, which is ran as root, which is game over. So yeah, 3 issues in Ubuntu Desktop. What I like about this article is that it shows that there are areas in like every operating system, but in this case Ubuntu, where people might not consider could allow you to get like a root privilege escalation. Like a lot of times I think when people think of rooting a Linux box or something, they think kernel exploit, right? That's like the go-to. But this shows that there's potentially easier routes that you can attack that can allow you to get that root privilege escalation. So yeah,
Yeah, I mean,
although in that case it was
SecUid
only
is
through
another
DHCPD.
common place where people look. Like there's definitely a lot of possible privilege escalations beyond just kernel exploits, but you don't tend to see them on hardened systems.
Yeah, exactly. So ZDI put out a Windows write-up, a DACL overwrite privilege escalation, which is through the group policy update mechanism. So DACL, for those not familiar with Windows terminology, that's the discretionary access control list. So the Windows group policy is typically used in environments like enterprise and schools and stuff like that. It's responsible for setting various policy settings, blocking off directories, controlling access to network drives, and setting password requirements like mandatory resets and complexity requirements. Um, where the issue comes into play is the fact that group policy objects are cached to disk, and this seems to be for performance reasons. So when the user policy settings are cached, they're cached to the program data Microsoft group policy users directory, and the system ones are cached to the Win32 or Win System 32 directory. But what's notable is the user policy one being cached to the program data. That directory is accessible to non-privileged users, unlike the Windows system directory. Now, you can't write directly to the top of that directory because it's owned by the admin group, and the users group only has read execute permissions. But when they dug deeper into the directory hierarchy under the session ID, they found a sysvol directory in the data store, which for whatever reason the user owns. It's not owned by the admin group like the higher level directories are. And every file in that folder has the potential to have its access list overwritten by system when a group policy update fires. And that includes junctions. So this wouldn't be an issue typically because the DACL that gets written isn't very permissive. It still only gives the user read and execute permissions. They don't get write permissions out of this. But they discovered a weird quirk. If you could somehow interrupt the write process for writing a discretionary access control list while it was being written, the user was granted full permissions instead of the more restricted read execute. They don't really go into why this happens. My guess is that they create the discretionary access control list object, and it's by default the user has write permissions. And then when they do an access check, the code that sets the more restricted permissions just gets skipped due to like a race condition or something. So the policy only gets partially written instead of fully written. The method they use to trigger the failure that leads to the bug is they delete the junction point before the write can complete. Part of the reason they chose this was because they could force the timing for the exploit to work by using opportunistic locks. Now, I don't really do Windows stuff, but op locks, as I understand, they're basically locks that you can place on files to make sure they don't get changed or don't get deleted while they're being read. So they can set an op lock on the junction, and once it gets locked, the junction point is deleted, and then the lock is released. So it's a cool attack. It wasn't as straightforward as it initially seemed like it would be, especially when you consider some of the junction type attacks we've seen lately. I do wish the write up went into more detail, though, on some of the specifics of why the access list is only partially written instead of completely written. Because when I read this, I was like left feeling like I was being scammed out of like some really interesting details, you know?
Being scammed out of some deep details, yeah. It could just be the case that they don't know. They just noticed that it did this and didn't really dig into it. It's not like Windows is open source to easily find out something like that.
That's
My
true.
guess, rather than a race condition as you supplied, I'm guessing it's just an early return issue where they have like their normal return path, and then when it returns early, because it hit that lock and failed, it just skips out that code. Like, I don't think there's necessarily a race condition in there. I think it's just one of those classic early return issues. Although I couldn't tell you why it's writing the higher privileges in the first place.
It seems like a bad default, uh,
Yeah,
in
I
a
don't
way.
know. But I feel like odds are the author doesn't know either. They just know it does that. They noticed the quirk and it took advantage of it without needing to understand exactly why the quirk happened.
Yeah, this is one issue where I wish I had a little bit more of that Windows experience and knew how discretionary access control lists worked under the hood. Because I feel like that insight could be really cool to get and could be provided by somebody who does Windows stuff a lot. But that's just not really my wheelhouse. So unfortunately, I can't really, I can't do much beyond wild speculation, really, based on the details that are in this report.
Wild speculation is what we do.
That's what we do best. Keeping on the Windows train, we have a Windows kernel pool-based buffer overflow. This was reported by Project Zero. It's a pool-based buffer overflow in the Windows kernel cryptography driver, which is cng.sys. So they have a function, CFG ADTP format property block, which is eventually invoked by one of the driver's ioctl routines. They don't name the ioctl routine; they just have the command number, which is hex 390400. Um, for those watching and can see the code on the screen, the issue is on the second line in the code snippet they provide. So they take a user provided source length and they multiply it by 6 before casting it to an unsigned short. And then in line 3, they use that size to allocate the buffer that they operate on, which has the input data combined with a static string. But in the for loop, when they operate on that buffer, they use the original input size, not the destination size they calculated. So if you pass in a length that's greater than hex 2 AAB, the size overflows because it's only a short, and it ends up allocating a really small buffer. And then in the for loop, when it goes to use the original larger length, there's an overrun there. So the overflow does look a little bit constrained by the code. For those who can look at the code, you can see they use the input bytes as selectors into a string that contains an ASCII representation of hex characters. But given the fact that this was exploited in the wild, someone managed to take advantage of this in a way that was assumedly able to achieve code execution. So I am interested in how this constrained or like out of bounds write could be used. Um,
I mean,
but yeah,
there's definitely like a lot. It's going to be near some very important structures because this is
for
in
sure.
non-paged memory. So like there's going to be other important kernel structures around this. So I don't know what it was. Like you, I would love to know what the exploit strategy was for this. Because it was found being actively attacked. That's why Project Zero dropped this after just 7 days. And there's a planned patch on November 10th.
So still a
Uh,
0 day.
yeah, it's still exploitable, or should still be exploitable on a lot of systems right now. And when this goes out on Spotify and all of that. But still, I mean, you're probably near some valuable things in memory, is all I'm saying. So I would imagine something there you could overwrite to take advantage of. I don't know the strategy, but that's my feeling is maybe with a little bit. I don't know how much like feng shui you could really do with non-page memory. Do you happen to know, like, is that really an option, or are you just kind of I mean, I guess you should have the option for at least a bit of that sort of coercion.
Yeah, I I can't really offer too much insight there, unfortunately, where I have the knowledge gap when it comes to Windows. Um, but I wonder if we will see some explanation of the exploit strategy, because where it's Google Project Zero, they have done blog posts in the past of exploits they've found, like in malware and stuff. Like I think Maddie Stone kind of specializes in that, right? Um, Maybe we'll see a blog post that talks about how this issue was exploited, because I feel like if there was a time to do a write up about that, this feels like the perfect scenario to do that, because it just seems like a very constrained issue where you have to use these ASCII characters and you don't even have the full ASCII character set available to you. You only have the ASCII characters between 0 and F in the printable ASCII range. So, yeah, I mean, one thing I could think of is maybe like corrupting a reference count or something somewhere, maybe. But that, again, that's just like a speculation. I don't know exactly. Maybe you could use it to smash the size of an object, actually. It's like if there's a vector that's being used in an object that's close by, you can smash the size using the ASCII value to create a more powerful out of bounds write somewhere else. I can see that being like using your limited corruption to get more useful corruption. I think that's probably what you'd have to do with this type of issue. Um, but yeah, as we said, given the fact it was exploited in the wild, it's definitely possible to do in some kind of way. Now, there was a bit of political weirdness in this discussion too. If you scroll down to the comments, there was a comment that said, confirmed with Google's threat analysis group or tag. This is not related to any US election related targeting. It seems really awkward to throw that in there. If it's not related, then why even say it? It almost seems like you're feeding into the fear and doubt around elections, which feels kind of irresponsible to me. Um, I don't know what your thoughts on Z. I don't know if you even noticed that, but
I
I feel
did,
like that
and
is really irresponsible.
it felt a little bit weird. However, I feel like there's probably maybe some concern, obviously, with the election coming up right around now,
It's
like,
like
literally
tomorrow.
tomorrow.
Yeah.
I could understand why there's maybe just some concern that, oh, and it's being used for that. So they want to preemptively confirm that it's not being used for anything like that, or that they haven't seen it being used like that. That would kind of be my guess, is that it might have just been a preemptive action because somebody may have privately raised the concern.
Yeah, I mean, maybe I'm just being a bit cynical, but it just seems like something where if it's not tied to it in any way, that just seems like something you would keep silent. You wouldn't advertise that, you know?
I get where you're
Because
coming from, but I feel like there maybe were enough like rumors going on, maybe like internal at Google, that warranted it. 'Cause I could understand where people are coming from if it's like, hey, there's a exploit being used in the wild. Just the timing would be perfect to say it's election related, so they just want to get ahead of any potential rumors coming from it rather than trying to feed into it, just being aware that rumors could be started. You can kind of go both ways on saying don't mention it. That way you're not feeding into the problem. Or in this case, you're getting ahead of the potential problem before the media runs away with this and makes some assumptions, for example. Because it would be much worse if they had to come out after the fact and say that. So if there was any reason why they would feel like somebody could run with this and try and claim that it was being used for election stuff, then it does seem like a reasonable move to actually confirm it's not.
yeah, I mean, now that you mention it, I do think that is a fair point. We don't have all the information. It is likely that the internal teams at Google that discovered this issue being exploited in the wild, um, if they found it in the wild, they know what it was attached to and they know some information that's not here that we don't know. So maybe there was some of that internal information that made it made that clarification necessary. So yeah, fair point. That's pretty much all I have to say on that though, and that wraps up our exploits. We'll move into the shoutouts portion at the tail end of the episode. So I have two shoutouts and Z has two. My first one is Vector 35. They released all the core architecture plugins for Binary Ninja. So we covered before in episode 48 that they released the ARM and ARM64 core ones. Um, and but at the time, those were the only ones that they released the source code to. They said later on that they'd be releasing other ones, including x86 and PPC, and that day has come. On October 30th, they released the MIPS x86, x64, and PPC architecture plugins along with the ARM ones they had already released. So that might be of interest to some people out there. Again, stipulation, it is uh, bound to the Binary Ninja API, so it's not like you could just take this code and use it anywhere. You would have to decouple it, and I do not know exactly how easy that would be. Um, but yeah, that might be of interest to some people out there, especially people who like Binary Ninja as a product, and people who might want to contribute. That is probably the reason they're putting it out open source, is they want people to contribute to those architecture plugins. My second shout out is a post about how debuggers work, which is about getting and setting x86 registers. This one is a little bit old. It's from October 22nd, but I still wanted to shout it out because it gives some cool insights that some people who don't have a lot of experience at the low level might not know about how debugging works. Working with the ptrace API, for example, the existence of the debug registers and stuff like that. Some of these things might be obvious to people who work at that level frequently, but I'm sure this will definitely be useful to some people out there who didn't know about it, and we'll be able to glean some insights from this post. That being said, I'll let you jump into your shout out, C.
Yeah, so I had two shoutouts here, more learning. Well, I guess your how debuggers work is definitely learning based, but I've mentioned before about CodeQL. I've got an interest in it. It seems like an interesting language, but it's a real pain to learn. I can't remember which episode it was when I was last talking about CodeQL. But I had mentioned kind of the CodeQL website, like Semel. They have a tutorial that kind of has you doing these investigations on CodeQL, or using CodeQL. It really focuses on teaching you kind of the query aspects of CodeQL, but it doesn't really cover how to use that in a code base. So like the concepts of like querying for guards around code, for even just querying kind of the control flow in general. Doesn't really include anything like that. And I came across this course on lab.github.com, one of their kind of GitHub training things that uses CodeQL to actually find some bugs in a actual open source project. So I haven't gone through it, but it looks like it's better than kind of the investigative version, because it's actually going to give some more practical aspects of CodeQL for code. And that was kind of my big issue with the other one, is that you would work through CodeQL and you'd work through their training. You just don't really reach an area where you can actually write CodeQL to find vulnerabilities. It wouldn't take you far enough, and I feel like this might be kind of bridging that gap a little bit better. So I'm kind of excited to take a chance to go through this myself. I guess I'm talking all about this CodeQL. If you're not familiar, it's a code query language. They'll provide some databases, or you can build a database for a block of code, and you're able to kind of or not for a block code, but for like an entire project, and you're able to query different features or traits about it. You can query kind of the data flow through the program. Offers a lot of ways to potentially find vulnerabilities, or especially if you find a vulnerability, to write a query that can kind of match that vulnerability in other areas of the code, and do kind of variant analysis. It seems like it has a lot of potential to augment a security researcher and the workflow of looking for vulnerabilities. So I just wanted to call this out, because the only other way I know of to kind of learn that aspect of CodeQL is if you basically look at existing CodeQL. So there are some out there. Mozilla has a bounty on writing CodeQL for previous CVs. So yeah, I want to kind of shout this out. And the last one is another course. This one is not free, but I've talked a few times about not really having a good resource that's just all in one to recommend to people as a single single resource to kind of start off at the beginning and work your way up to relatively modern exploits. Like, I often recommend open security training in their introduction to software exploitation course. We've got a whole video talking about some recommended resources. This one is a $1,000 course, so it's not the most accessible course. I don't think it's an insane cost, but I do think it's an interesting program. So one, content wise, it looks like it covers fairly reasonably like everything you'd kind of need to know up to more modern issues, heap overflows, use after freeze, various race conditions that are more popular now, but still talking about the past stuff, past issues, so, dealing with mitigation stack cookies, ASLR, DAP, all of that. What I thought is interesting about this is you don't have to do a lot of environment setup for it. Their demo, they've got the demo you can try. It basically just has everything. I'll pull up kind of one of these challenges. So it basically kind of has this gamified guide that walks you through exploiting a program. Out of chat, but is an environment setup important for late? It is, and they do use something that is reasonably realistic. It's just a lot of times especially when you're dealing with older, more vulnerable binaries, you have to go through a lot of work to get that set up. And so I feel like this is just kind of an all-in-one approach. It is expensive, like I said, at $1,000. It's not the cheapest thing you can do, but it does look like a pretty interesting source, and it looks like it covers quite a bit, still at a reasonable price. And it has kind of an interesting system that they're able to hook and kind of gamify for you to learn on.
It's a lot like Codecademy, if anyone's ever used that. The layout is extremely reminiscent of that. You're able to just quickly write code in the browser and run it and get that instant feedback, which is something that's been sorely lacking when you're talking about exploits, because it's just such a it's much more complex to try to test for from an automated standpoint. So yeah, it's cool, and I think this is the first time I've seen that applied in the security area.
Yeah, I think this has like a lot of promise as a course. Like, I kind of feel like throwing some money at it just to kind of run through it and see what it's like. But because it is kind of all in your browser, you're able to kind of learn through there. You're able to walk through everything. Over 50 labs for you to work through, and several challenges that it doesn't walk you through. So I wanted to shout them out. Unfortunately, I haven't actually tried it. It was mentioned to me by somebody I was chatting with during last week, just how I kind of came across it. But it looks really good for a online exploit dev course.
Yeah,
you're going to say something.
Yeah, I was gonna say, like, this course is hosted by Ret2 Systems, and they're a pretty reputable group. There's some really cool researchers who I've listened to like conference talks to and stuff who work for Ret2 Systems. So it's a reputable course offer. It's not just some company that's kind of popped up out of nowhere and provided the course. So that offers some additional reassurance. Something I liked looking at the course syllabus as well is the fact that it seems they do have at least somewhat of a focus on the vulnerability research angle, talking about like code patterns that can lead to double fetches and races and stuff like that. And I feel like the vuln research angle, especially when it comes to those types of bugs, are severely underrepresented when it comes to courses. Usually they just focus on some of the basic exploitation stuff. They don't focus on the VR angle very much. Thanks for the 1,000 bits, by the way, Wolfgang Blitz. Really appreciate it. But yeah, like, it just feels like this course covers some things that seem to be skipped over in some of the other courses that I've looked at in the past. It does have some of the older stuff though, like shell coding. Shell coding isn't necessarily going to be super relevant for modern exploitation. Write execute or write no execute is pretty common. It's going to be used pretty much everywhere. Maybe you'll find some like IoT stuff that doesn't use it, but for the most part, shell coding, at least in its original sense, is dead. So, but they do talk about some more modern techniques as well, like the ROP and the stack pivoting and stuff like that, which you mentioned
Yeah, and
earlier.
I think there's value actually in the shell coding, because that comes in when you're talking about C fundamentals, reverse engineering, memory corruption, shell coding. So I mean, that's kind of giving you that assembly, or helping you kind of gain that assembly understanding that you need. I can't imagine the reverse engineering is, complete and everything you need. So I feel like the shell coding kind of helps cement that also. So it has its value, even if you're not necessarily writing a lot of exploits that are based around just injecting your shell code anymore. And to be fair, IoT stuff, which is one of their sample missions, or not sample, is one of their tests during it, is an IoT mission. IoT, you can definitely still be seeing plain old shell coding. I will also mention that this is $1,000 for 3 months of access. I should have mentioned that earlier, but it's 3 months of access to their lab, and there isn't like video or anything you get along with it. Like, it's the lab system that is the entire course.
So, one thing I didn't really see anything about, there's no cert attached to anything like that here, right? It's just the course and the learning aspect. There's
That's
no like
correct.
certification attached.
There's no cert, I think, and I don't think they should. I think the value of this does seem to be, well, actually, the whole environment, I think, has a lot of potential. Like, I could imagine them doing more courses based on this setup.
For sure, but I do think that $1,000 price could be seen as a bit steep.
Oh,
Because there's no cert attached to it. Yeah.
I wouldn't imagine the cert really adding too much, honestly. Maybe they could if they did a good cert. I suppose it could be, but oh no, the price is high. I'll agree with that, with or without a cert.
But yeah, it does look like a cool course and has some cool content there, so might be worth checking out. I think we'll wrap it up there, though. That concludes all of our shoutouts and all of our topics for today. Thank you to everyone who tuned in. I see CTS is still stuck around with us. Still hanging out there. We thank you for coming on. That discussion around the fuzzing paper in academia, I think, had some really cool insights in it. So we really thank you for
sorry
taking
for the
time out
mic
to come on.
troubles.
Yeah, no worries. I mean, it's something that's pretty much impossible to fix on the fly, unfortunately. But yeah, you were still understandable. So yeah, still led to a really good discussion. So yeah, we'd like to thank you for coming on. Everybody watching, you can catch the VODs on Twitch or on YouTube at 6 p.m. Eastern, 3 p.m. Pacific on Tuesday after the stream. We also have previous podcasts up on Spotify, Apple Podcasts, and more links on Anchor. Make sure to follow us on Twitter and join our Discord if you want to join the community. We'll be back again next Monday at the same time, 3 p.m. Eastern, 12 p.m. Pacific. And we will see you guys then.